let's attempt this question on the board. These are two different questions. We'll solve them simultaneously, okay, one by one. So the first one said the rate constant for the decay of radon is 0.810 per day. Okay, what is the half-life expressed in days? Okay, so remember that half-life is equal to 0.693 over what? The decay constant. Okay, which is the same thing as what? Natural log of 2. So from here, T half will be equal to 0.693 all over 0.810. So when you divide that stuff, when you divide 0.693 by 0.81, you get 0.86 days. So this is the half-life of this expression. Now for this, we are told to find, they said, an isotope of strontium has a half-life, okay? So the half-life was given as 28.1 years, okay? Calculate the amount of 0.050. So this is the amount of the isotope that we should find the amount, or calculate the amount of 0.050 gram sample of the isotope that will remain. So how much of this guy will remain after this year? So N naught, this is the what? Original amount, which is 0.050 gram. And then the time what taken to decay is 5.25 years. Then we are looking for the amount that will remain. The amount that will remain after taking this long. Okay? So what do you do? Since half-life is involved, you remember the equations I gave you, right? So I'm going to use 0.693 all over half-life is equal to 2.303 all over T multiplied by log NO over what? N. Okay, let's substitute the values. So we have 0.693 all over 28.1 is equal to 2.303 all over what? 5.25 times log NO is 0.050, okay? All over what? N. So what next? So we can either cross multiply and do our mathematics, okay? So anyone you want to do is fine. So you can divide these two, okay? We can divide these two. So when we divide our two, what are we going to have? We are going to have 0.025. Okay? So if you divide this, let me confirm. If you divide If you divide 0.693 divided by 28.1, yes, you have this. Okay, so if you have this, let's divide this one at once. We have 2.303 divided by 5.25. So we're going to have here to be 0.4387 equal to 0.4387, okay? Log 0.050 over what? N. So we're going to make this log 0.050 over N subject of formula. So I'm going to clean this side. I'll clean this side, okay? I want to finish the solving here. So quickly, we will make this guy sort of formula. So we have log 0.050 over N is equal to, of course, this will be dividing this. I have 0.025 all over 0.4387. So when you divide this, what will you have? When you divide 0.025 divided by 0.4387. So you have 0.05 or 0.057, okay? So we have that log 0.050 over N is equal to 0.057. So taking this log to this place becomes anti-log, okay? So I have 0.050 over n is equal to antilog of this value, 0.057. Okay? So when you punch the antilog of that value, let's clean here. So once you punch the antilog of this value, that is, how do you get antilog? Just press shift in calculator plus log. Shift plus log, antilog. You put this value. So you are going to have 0.050 over n is equal to antilog of this. You will get 1.14. Okay, 1.14. So you cross multiply and make n subject. So n will be equal to 0.050 all over 1.14. So the value for n will be 0.044 gram. So this is the value of n. Okay, so this is how to solve this. Now there is another method you can use to solve this. Okay, that method will just involve us putting the value from the kinetics equation. Okay, the proper equation. We can solve it using this equation. N is equal to n naught exponential minus kt, or this k is what? Lambda. Okay, we can solve it with this also. Okay, so we have to get this one first. If you get n is equal to 0.693 over what? Half life. So if you get this using the half life, you now put this value here and now press the calculator. N is equal to, put this value, the original amount is 0.050, multiply exponential minus the value you have here. So you put the value you are going to get here and then your time. So when you plug in this value, you can also get the answer. The same thing with me. Okay, you can get the same thing with me. Let me show you what I mean. What I mean is this. Let me clean here. Okay, let me just clean here, show you what I mean. I mean, we can solve using n is equal to n naught exponential minus this. Okay, so already our decay constant, how do we get this? It's going to be this over this, this over this, this over this is equal to this, and we have the value as 0.025. So it's going to be n is equal to original amount. What's the original amount? The original amount is 0.050 times exponential, or you can just put exponential minus bracket open 0.025 times 5.25. The time is 5.25. Okay, so that n will be equal to, you multiply this and then find the exponential. So if you do the multiplication, if you multiply this and find the exponential, how do you get this? You get it by pressing shift plus natural log. This will give you this. Press shift calculator and you press in, you get this. So when you punch out this and multiply with this, you will still get 0.044 gram. The same answer that we got here. You still get the same thing. So this one is quite short, but most of the times the reason why I don't want to use one is because if you don't know how to make something subject of formula, let's say now, for example, let's say we are looking for T. You might not know how to make T subject of formula, so it's better you use the one that is much more easier, which is this one. You can keep solving until you can be able to make T subject of formula. But if you're looking for a final amount and you know all these things, this is the shortcut to this. Okay, but if it's a theory exam, it's advisable that you show working like this. But if it's a multiple choice question, just to click A, B, C, you can use this one to easily get the answer very fast.